You take this one, the carbon which is attached to three different alkyl groups, and one side it is attached with the bromine. Now this bromine is replaced with the nucleophile. It can attack from two sides. One is from the bottom, or it can attack from the top. There are two chances are there. So you can see here the top attack and the bottom attack. If it attacks from the top, then whichever the way the bromine is releasing, the same way the electron rich group is attaching here. The nucleophile is attaching here. So the same way here the leaving group is leaving, on that same direction the nucleophile is attaching. So that's why we call it as the retention of configuration. That means you are not inverting its configuration here. But if it is attacking from the bottom, then the nucleophile now it is attached on the down, not on the top. So there is a inversion of the configuration happened. Okay, you got understood this? So what's the possibilities here? There could be from the top side attack. When it is attacking from the top side, what happening? There is a retention of the configuration. If it is attacking from the bottom, the nucleophile, then there is a inversion of the configuration. See here, whatever the bromine is there, this bromine is exiting here. It is leaving, exiting. Okay. And from the bottom, the nucleophile is joining. So whatever the configuration is there, it is inverted here in the second condition. In the first condition, it is in the same direction. So the first condition, we call it as the retention of configuration. The second condition, we call it as the inversion of configuration. You understood this much? Any doubts here?
No.
Okay, great. So just remember these points. So first we know SN1 reaction, how does it start? It starts with the formation of the carbocation. So how does it start? By formation of carbocation. Yes or no? So here the carbocation, once it is formed, then what happens then? Then there is a water molecule will come and attach here. So when the water molecule come and attach, what happens now? There is a carbocation intermediate will be formed. So carbocation intermediate, or you can simply directly write it as the formation of the carbocation intermediate. Okay. And remember here, which hybridization is it? It is sp2 hybridization. Okay. So whatever you are seeing here, it is a sp2 hybridization. Remember this. Okay. There you will be seeing sp2 hybridization. And not only sp2, the other thing you need to remember in this, it is a planar structure. You can see here. You can see here. It's a planar structure. So that's why, as it is a planar structure, there is a possibility from the top side attack and from the bottom side attack. Understood? So there are two possibilities. It could attack from the top or it could attack from the bottom, as it's a planar structure. So remember, as it is a planar structure, you need to remember this. So here the attack can be the nucleophile can attack from either side. You can say, okay, from either side. What is meaning of either side here? Either from the top or bottom. Okay, if it is from the top, the inversion will be same. Sorry, there will be no inversion. The configuration will retain same. If it is from the bottom, it will be inverted. Mandara, you understood this thing?
Yes, sir.
Any doubts here?
No, sir.
Yeah, good. So once this is over, so next what happens? Second thing you need to remember whether the reactant is chiral or not. Okay, so whether whatever the nucleophile that is attacking the carbon, whether this carbon is chiral or not. What is meaning of chiral?
Carbon group attached to different elements.
Yeah. So only in the chiral carbon there is a possibility for enantiomers to form. Okay, if it is not a chiral carbon, then the formation of the enantiomers is not possible. Okay, so that's the second thing you need to remember. So when the reactant is chiral, so then there is a formation of enantiomers. What are enantiomers? What are enantiomers? Structurally similar, but they are, I mean, chemical formula is similar, but they can arrange into two different ways. Okay, so that's called as enantiomers. So when the reactant is chiral, the formation, there could be a chance for the formation of enantiomers. So this property we call it as racemization. Okay, so this is called as racemization. Remember this. Okay, so what is meaning of racemization? When the reactant is chiral, both nucleophiles can attack from the top or bottom, so that you will be finally getting the two different kinds of structures. So that two different kinds of structures, we call it as the enantiomers. And this property is called as racemization. Okay, so you can see here, this is the first structure and this is the second structure. So one is inverted, the other one is retented the same way. So this we call it as the racemization. Okay, but which one will be formed more? Practically, if you see, there is a slightly higher proportion for the inverted product compared to the other product. Okay, so if you see the practical scenario, so slightly higher proportion for the inverted product compared to the same one. Okay, so why could be this thing can happen? There could be two reasons. One is there is a intimate ion pair formation. Okay, so whatever there's a the one which is present here, the bromine and carbon, both are could be a very intimate. As both are very intimate, it is very difficult for to separate the carbon and bromine. Okay, so they will show here the resistance of the leaving group. So it depends on the resistance of leaving group. So due to this resistance of the leaving group, so it takes a lot of time. So this will have to release and then the other one has to attack. So instead of this direction, we'll be seeing the opposite direction. So when this guy was completely left, the other guy will be eating from the opposite direction. Okay, leave about all that. Just remember, in practical scenario, there is a slightly higher proportion for inverted product. That is due to the resistance of the leaving group. Okay, so this is due to resistance of leaving group against the incoming nucleophile. Okay, so remember this, against incoming nucleophile. Is this clear? So these are the three things you need to remember. First one, SN1 reaction. There is a carbocation intermediate is formed, which is sp2 hybridized and it's a planar. So this planar structure allows for a nucleophile to attack on either side. So that's the first thing you need to remember. So when the reactant is chiral, the nucleophile can attack from both the sides, from the top or from the bottom. So there are two structures that could be formed. So we call that as enantiomers. And this process is called as racemization. Next one, in practical scenario, slightly there is a higher proportion for the inverted product compared to the other one, the normal product. That's due to resistance in leaving group against the incoming nucleophile. Okay. So because of this racemization, there is a inversion of configuration. Remember this. So is these points are clear for you, everyone? Please say yes if you understood, or no,
Yes.
or repeat. I'll repeat again.
Yes, sir.
Sir.
Okay. So can I go for the next?
So can you just keep this slide for
Yeah, yeah. Okay, write it fast, Nitya. Nitya, is it over? Come on, we need to discuss 30 slides, 35.
yes, sir.
Okay. So no, next one you see here. So this is the retention of the configuration where the nucleophile is attacked on the same direction. And here there is an inversion of the configuration where the nucleophile is attacked from the bottom. Okay. So this is called as the partially racemization. Okay. So here you are getting there is a retention of the configuration as well as inversion of the configuration. Okay. And if you see in both, which one will be formed more? Is that a retention of configuration or inversion of configuration, which is slightly higher proportion? Come on, guys. In the previous slide, I just said. So in the practical scenario, there is a slightly higher proportion for the inverted product. So tell me, is that the left one will form more or the right one will form more?
Inversion.
So if you see, this is more than 50% and this is less than 50%. Remember, this is slightly more forward. Okay. So this is slightly more forward. So it is more than 50% and this is less than 50%. And this is happened due to the partial racemization. Okay. So what is meaning of partial racemization? So there is a slightly higher proportion for the inverted product that's due to the resistance for the leaving group for the incoming nucleophile. So remember that. Okay. Anyway, I wrote that. Okay. So remember this. This is called as the partial racemization. Okay. So you can see here. First, suppose this is the leaving group, and this leaving group just left, and it formed the carbocation, which is a positive charge, and leaving group negative charge. So once that leaving group is left, now the other strong nucleophile will come and attack here. Okay. So you can see here. What is this? What are these two? Is that an electrophile or nucleophile?
Nuclear.
Yeah, it's a nucleophile. So you can see here, there is a less stronger nucleophile is leaving, and there is a there is a less nucleophile it is leaving. The stronger nucleophile is attacking. It could attack from the top or it could attack from the bottom. It could attack from the left and it could attack from the right. Okay. And from which direction the other nucleophile is replacing, or the bromine or whatever you take halogens, it is leaving from the right. And here the same nucleophile is attacking from the right. So this one will be the retention of the configuration. And this one is the inversion configuration. And inversion configuration will form slightly higher. So it is greater than 50. and this is lesser than 50%. So remember this. Okay. So there is a nucleophile which is attacking, and it could attack from the left or right. And based on that, we, or you can say from the top attack or the bottom attack. Okay. So if it is attacking from the top, that could lead to the retention of the configuration. If it attacks from the bottom, that results in inversion of the configuration. And we know the inversion of the configuration is slightly more compared to the retention. So this will be formed more. If it is 60 molecules, this will be 40 molecules out of 100. Yeah. So now tell me this, what is the answer for this? Okay, Mandara, you tell this answer.
Oh,
Mandara, you tell the answer.
Yes, sir.
Yeah, what is the answer for this? Come on, make it fast. I told you some, even right now by 10 times I said this.
Yes, sir.
Yeah. So in a SN1 reaction on a chiral center, there is 100% inversion, 100% retention, CS3O minus, and there is an inversion more than retention. That we call it as partial racemization. What is the answer? Mandar, are you in the class so far or just now joined?
No, sir, I was there.
Then why you are taking this much time for this?
I'm confused, sir.
Wow. What about you, Srikar? What is the answer?
so 100% retention?
Great. Nitya?
No, wait, sir, it's option B. Sir, it's
Yeah,
option.
Diya, you're correct. You're correct. I told you 100 times so far. See, I told you here, there is a two configurations could form. Retention of configuration, inversion of configuration. Here also I told, in practical scenario, slightly higher proportion inverted product. So that's the resistance of the leaving group against the incoming nucleophile. And I told you, there is a slightly greater percent for the retention of configuration and lesser for the inversion. Sorry, further greater further inversion of configuration and lesser for the retention of configuration. And I told you here as well. So we could get two products. I told you out of 100, if this could form the 40, this would form the 60. Sorry. This could form 40, this could form 60. Now that is the basic question. In SN1 reaction on chiral center, what will be the result here? It's the inversion more than retention. That's leading to the partial racemization, which I just told you. Partial racemization. What happened to you, Mandara and Shrikar? Are you guys are listening or not listening?
Listening, sir.
Am I going too fast or going too slow that you couldn't catch up?
No, sir, it's not like that.
What about you, Shrikar?
No, sir, I was confused between B and D, but then yeah, I chose D.
Why you got the option D?
Because inversion is more, right? So then, I mean, I don't.
Okay, in SN1 reaction on a chiral center, there is, okay, you said inversion is more. Then it should be 100% inversion, right? It shouldn't be 100% retention.
Mhm.
Remember here. Okay. So what's happening here? So there is a chance to attack from the top, to attack from the bottom. If it is attacking from the top, that would give the retention, but it is slightly lesser. If you say 100 molecules are formed, in that 40 molecules will be formed this way, retention, and slightly more it will form for the inversion. So 60 molecules will form for the inversion. So here he said in SN1 reaction, what is the answer? Inversion will be more than retention. Yeah, because we saw here it is slightly more and this is slightly less. And why that's happening? Because of the partial racemization. And I also told you what is the reason behind it. Because of the resistance it is offered. So resistance offered by leaving group. That means it don't want to leave. It want to stay back, but you are forcefully leaving it. So resistance offered by the leaving group. So this guy doesn't want to leave. This guy want to attach here. But he is showing the opposition force. He don't want to leave here. If he leaves, then only this yellow ball can attach. So that's what it means. There is a resistance offered by the leaving group over the incoming group. Or you can say to the incoming nucleophile. Mandara, you understood now?
Yes, sir.
Okay. So let's see two examples here. So first one, there is a carbon which is attached to all the sides with a methyl group. And there is a bromine. So in the presence of CS2OH Ag plus, it will form CS3C, CS3, CS3, OCH3. Okay. Here you don't have a chance to attack from the back or front. You can only attack from one direction because this is not a chiral carbon. Understood? So here we cannot see the racemization. Understood why we can't see the racemization in this case? Because the bromine doesn't have a chance to attach to this carbon from the back. It can only attack from one direction. So there is no chance or no possibility for racemization in this condition. But if you see another example, now it could have chance. This chlorine can leave. Once this chlorine leaves, we get the carbocation. Now this nucleophile can attack from the top or can attack from the bottom. So it has the two options and it can form two different kinds of products. So one product is COH, H, CS3, C2H5. The other product is OH, C, H, C2H5, CS3. Now tell me here, Sharon, you tell me which one will form more and which one will form less? Slightly more and slightly less. Is that a left one or right one?
Left one, sir.
Left one will form more. Okay, tell me this one is inverted or this one is inverted? How do you refer inverted means? We'll refer in terms of the leaving group. If the leaving group and the attachment both are in same direction, then we'll say retention. If both are opposite direction, that means it is leaving from the front, the other one is attacking from the back. Then we'll call it as the inversion. So now tell me, still you are okay with the left or right?
Right, sir.
Nitya, is it correct? Nitya, sir, I have a net issues. Your voice is breaking for me, sir. Is it happening for others as well? Someone can you confirm? Is my voice?
Sir, sir, can you
Yes.
hear me?
Yeah, Nitya, I can hear you.
So I sent it before sometime. That time the net was not proper. Now I guess it's fine, better.
Okay, okay. So tell me what could be the answer here? My question is which
So
product
the
will be
right,
formed more? The left or right?
the right one.
Right one. Yeah. So see here, here the leaving group is leaving which is on the right side. And if you see the nucleophile which is attacked, here it is attacked left. And attacked left and it is present on the left. So you can see there is a inversion in the configuration. If you see the right, this one, so this is also on my right side and the chlorine is also on my right side. So both are same. So we call this as the retention configuration and this is the inverted configuration. So inverted configuration will be slightly more than the 50%. So this will be the major product. This will be the minor product. Understood? Everyone? Is that clear? Mandara?
So, so
Yes, sir.
the leaving group, that side will be retention and the other side will be inverted. Can you say it like that?
Leaving group?
Meaning chlorine is going, so then can we say it is retention? Like OH is getting added, right?
The same direction where the chlorine is leaving, in that same place, if the OH attaches, then you call it as retention. If it attaches on the opposite, then you call it as inversion.
Okay, sir.
Okay. So here the chlorine is leaving from this direction. So if I still attach my OH this direction, then I call it as the retention. If I attach on this direction, I call it as inversion. Is that clear for everyone?
Yes.
Yes.
Okay, great, great, great. So let's see briefly what is this SN1 reaction so far what we discussed. So we saw in the last class, SN1 reaction is a unimolecular reaction. Can someone tell me what is meaning of here? The unimolecular reaction means.
Only one molecule
Yeah. So
reacts
here
at a time.
the rate determining step will be involved by only one molecule. Okay. So that's the unimolecular reaction means. So remember, SN1 reactions are unimolecular because the rate determining step involved in SN1 reaction is only one molecule, that is the alkyl halide, this RX. Okay, so that's why it is called as unimolecular reaction. Next one, partial racemization. Just we studied 50%, greater than 50%, it is inverted, less than 50%, it is retented the same way. So we call that kind of racemization as partial racemization. And what is meaning of polar protic solvents? So we saw SN1 reaction, if it happens in the polar protic solvent, it is most favorable compared to polar aprotic solvents. In SN2 reaction, tell me, is that polar protic solvents are favorable?
No, sir. It's apolar.
Yeah. So polar protic solvents are favorable for SN1 reaction, whereas it is unfavorable for SN2 reaction. So remember this. For SN2 reaction, it is polar aprotic is favorable. Next one, weak moderate nucleophile will be favorable. I told you whether it is showing the retention. We should not, I mean, resistance to leave. It should not happen. Okay. Next one, alkyl halide activity is 3 is greater than 2 is greater than 1. Okay. So tertiary is greater than secondary than primary. We saw that if the carbon is attached with more alkyl groups, then it will show more SN1 reaction. Whereas this is opposite for the SN2 reaction. So remember, if you remember the SN1 reaction or SN2 reaction and compare it with SN1, you will be remembering both the reactions at a time. That will be very easy way. So instead of studying separately, both SN1 and SN2, you study comparing each other. And rate determining step. So the formation of this carbocation. So whatever the X break is, and turn into R minus, R plus, and X minus. So this formation of the carbon cation, it is a very slow process. So as it is very slow process, so this is defined as rate determining step. And we saw it is a two-step reaction, whereas SN2 reaction is a single-step reaction. It's a one-step reaction. SN2 is one, SN1 is two steps. Is that clear? So yeah, come, someone answer this. Do you guys know what is meaning of vinyl position? What is vinyl position? If both the carbons attach it to a double bond, then we call it as the vinyl position. So if you see this one, here, this is the carbon, this is the carbon. Here, this carbon, now it acts like a vinyl carbon. And remember this thing. So whenever there is a vinyl position is there, that is a very least stable. So this one is not stable because of the vinyl position. Okay. So this reaction will not be proceeded by SN1 reaction. So remember this, will not be proceeded by SN1 reaction. So this will be not my answer. So next one, you see here, B. So here the cation formation occur at the phenyl position, which is also not stable because you can see here, there is a double bond carbon is present. Okay. So this reaction will not be proceeded because of the double bond here. Okay. And you see here, option C. So here the cation formation occurs at the bridge. You can see here, there is a bridge at the position. There is a one rule called the Bridet's rule. It's okay. You don't need to remember that. These kind of reactions, mostly they will not give. So there is a bridge at the position we say. So that's also acts like a very unstable one. Okay. It is not very favorable for the carbon cation to form here. So here the chlorine cannot leave here very easily. So this is not stable process. So you can see here, this is carbon and it's not having any double bond. So this carbon can easily break the chlorine and it can easily turn into a carbocation. So this will be my answer. So in this, carbocation formation can easily occur. And which carbon is this? It is attached to two other carbons. As it attached to two other carbons, so we call this carbon as secondary carbon. And secondary carbon, we know it is a very good. Okay, it can form. What is the order? 3 is greater than 2, 2 is greater than 1. So this is okay. It can form the carbocation, so it can proceed with the SN1 reaction. So my option is D. So try this. Here you need to find out which one is chiral carbon. If you see this one, here is this a chiral carbon? Is this a chiral carbon? Is this a chiral carbon? Or is this a chiral carbon? So just find out which one is a chiral carbon here. Guys, tell me what would be the answer. So what is meaning of chiral carbon? The one which attaches to different carbon where racemization could be possible. If I break the bond here between this carbon and chlorine, so can it attack the nucleophile from the other direction? Is there a possibility here? Can it
No.
attack?
No.
Because here, if you see the left one, it is attached with a three different carbons. So it cannot attack from the left side. So it can only attack from the right side. So can I form the racemization in this condition?
No. Sir.
So there is a no racemization in this condition. There is no racemization in this condition because my I cannot attack from the left side here as well because here these groups are present. And the same here I cannot attack in this direction. So it could only, just remember, you don't even need to think whether it can attack from the left or right. Just remember whether it's a chiral carbon or not. So I told you chiral carbon when it is attached with different groups. If you see here this carbon, it is not attached with different groups. It just attached with hydrogen and carbon. If you see here the same way here as well, it's just attached with the hydrogens. Sorry, this one, not this one. You see here, it is attached with the different hydrogens. So this could be a chiral carbon. If you see, this is one different group, this is one different group, this is one different group, this is one different group. So that's why this carbon is chiral carbon. So as it a chiral carbon, it can show the racemization. So only the option 4 is correct. Is that understood, everyone? So remember, any compound that contains the chiral carbon, that could only undergo the racemization. Remaining any other carbons, they are not chiral. If you see here, they just attach it to two hydrogens. They are not two different groups. So it is not a chiral carbon, so it cannot undergo racemization. Only this one attached with different groups, so it could be a chiral carbon and this can undergo racemization. So only option 4 is correct. Clear? Nitya, Shekhar, Mandara, Dia, Sharan.
Yes, sir.
Yes.
Okay, all right. Mandara, you understood?
Yes, sir.
Any other doubts?
Yes.
Sure.
Yes, sir.
Can I ask questions?
Yes, sir.
Okay, that confidence is enough. So major product for the following reactions. So if you see this one, so when I treat this in the presence of Ag and O3, there is a AgI will form and NO3 it will form. Okay, so remember there is a methyl shift, we will get the tertiary carbon, which is the most stable in this condition. First, suppose you see here. So this reaction will happen like this. Whatever the iodine is there, it will leave and this place will turn out to be the positive. So that's why we call this as the carbocation. So cation means the positive ion. So carbocation is formed. Then what happens? So remember, this is a secondary carbocation. Because if you see this carbon is attached to this carbon and this carbon. So it is called as the secondary carbon. Okay. And here there is a methyl shift will happen in this step. So whatever this methyl group is present, whatever this bond is present, it will just move here. So that we call it as methyl shift. Whatever the R group that attached here or the single carbon that is attached here. So one carbon will just shift to this positive carbon to make it stabilization. So that stabilization, we call it as the methyl shift. So when it moves this way, this carbon now lost the methyl group. So this will turn out to be positive. So now I got a tertiary carbon as my carbocation. So why I call it as tertiary carbocation? So if you see this carbon is attached to this carbon, this carbon, this carbon. So it is attached to three different carbons. So I call it as tertiary carbocation. Now in presence of this water, so it will attach on the this carbon. Okay, this positive charge. So whatever the OH group, the nucleophile is there, now it can ready to attach at the tertiary carbon. So we know the order as well. So always the SN2, SN1 reaction will proceed on the tertiary carbon. So tertiary carbon is favorable for it. So it will form there. Otherwise, the secondary carbon, the OH group could attach here, but secondary carbon is not much stable compared to the tertiary. So tertiary is more favorable compared to secondary. So there will be methyl shift will happen. Whatever the this carbon is having two alkyl groups here, one alkyl group will go here, one methyl will go here. So as it went here, now this is the most favorable one. So understood how this reaction has proceeded. So this is the desired product we say because compared to the secondary, it is the tertiary. So tertiary is more favorable compared to the secondary in the SN1 reaction. Everyone understood? Any doubts?
So could you repeat the last part again?
See, we what is the reaction order for tertiary, secondary, primary? Shikhar, tell me. Is
Three.
this or this?
Second one.
This one? Yes or no?
Yes.
So now we got this. Okay, I removed the I in presence of AgNO3. This I will attach to the Ag, and whatever this NO3 is there, it will form into minus. Leave about it. We don't care. Now see here, when the iodine is left here, there is a cation formation happened. We know this is the first step in the SN1 reaction, which is a very slow process and rate determining step. Okay, somehow we form the cation. So once the cation is formed, I have a two chances. If you see the carbon here, it is a secondary carbon because it is attached to two carbons. So we call this one as the secondary carbon. But if there is a methyl group that is present here, if I move this methyl group onto this carbon, then I could get my positive charge on this carbon. If I get my positive charge on this carbon, this could form into a tertiary carbocation because you can see here, I shifted this carbon on this second carbon. So when I shifted, now I got the positive on this carbon. If you see this carbon, it is attached to one, two, three, three different carbons. So this will be my tertiary carbon. And we know tertiary is more favorable. That's why this will be my desired product. Everyone understood? Any questions? Why this happened this way? Why couldn't simply the OH can attach here? Instead, why there is a methyl shift happened here? Is that clear?
Yes.
Nitya, Mandara?
Yes, sir.
So,
Okay. So next one. So tell me this one. See, what is the basic difference between SN1 and SN2? Okay, at least tell me if there is a carbocation formation is there. So is that SN1 reaction or SN2 reaction?
SN1.
SN1. If there is no carbocation and directly it turns into a final product, it is SN2. Yes or no? And what is the order for the SN1 and SN2? 3, 2, 1. For SN1, it is tertiary is greater, secondary, and primary. For SN2, this is for SN1. The opposite happens. So primary, secondary, tertiary. So tell me by this as well.
option A, sir.
SN1 and SN2. The mechanism of reactions 1 and 2 are. Okay. Others, please tell me, what do you think? Is that option A is correct?
Sir, I'm not able to figure it out.
Okay. Anyone else? Okay, no problem. We'll see. So remember one thing. Let's see first one. Okay. If you see here, if mechanism one, okay, sorry, if this one will follow the SN1 mechanism, okay, then what will be the product will be formed here? So there will be formation of the carbocation will involve because it's a SN1 reaction. As I said, if it follows the SN1 reaction, so it will go with the carbocation formation, and definitely there will be hydride shift will happen, and product will be obtained different compared to this one. Okay, I didn't tell you what is meaning of this hydride shift. Should I tell now? So remember, if this happens with SN1 reaction, there will be hydride shift. I'll tell you that later. In the next class, I'll tell you. So the product, whichever it is obtained, it will try to form the Br here. Okay. So whatever this group is there, whatever this is there, it will try to attach here instead of this because it will be more favorable for the SN1 reaction. Okay. Because tertiary is more favorable compared to secondary compared to primary. Right now, you just remember this way, leave about the hydride shift. Okay. So you see here, we know the tertiary is more favorable compared to secondary compared to primary. Okay. That happens for the SN1 reaction. But if you see here, this is not at all the tertiary carbon. So this is just a primary carbon. As it is a primary carbon, this will be less reactive. So it cannot form with the help of SN1 mechanism. It will only could able to form with the help of SN2 reaction. Just remember like that. So SN1 reaction doesn't like to form on the primary compared to tertiary. So this will be not following with the SN1 reaction. It will go with the SN2 reaction. Is that clear?
Yes,
So
sir.
understood why the one will go, the product formation will be more favorable for the SN2 mechanism compared to SN1. Leave about the hydrate shift. Just remember this way, as it is a tertiary carbon and this is a primary carbon, the primary carbon will not try to form the product. We know the order, reactivity order, tertiary, secondary, quaternary. So this will be least formed product if it goes through SN1 reaction. So as it is a least formed, it will not try to attach here. Instead, it will try to attach somewhere here. So if it attaches here, we'll be getting slightly different product as we saw here in this. Actually, it could able to attach here, but it's not attaching here. Instead, it is attaching here. That's because this is the secondary, but there is a chance for tertiary to form here. So that's why there is a desired product we said. So here, the same way here as well. It is not the desired position, it's the desired position. So SN2 can happen here, SN1 can happen here. So this will take as SN2. Because we know SN2, the main is primary compared to secondary or tertiary. As it is a primary carbon, so this is the more suitable position for SN2 reaction. Is that clear? So I told this as SN2 instead of SN1.
It's clear, sir.
So what about this? Now you see here, it's given C2H5OH and C2H5O minus. That means whatever the electrons present on the hydrogen, it is given to O. As it is given to O, now it become like O minus. Understood? So as it become O minus, so SN1 reaction we know nearly always involves the weak nucleophiles. But what happens if it involves the strong nucleophiles? They are too reactive to allow a carbocation to form. Yes or no? So we know SN1 reaction, first it needs to form the carbocation. First it has to form the R plus. When it forms the R plus, it is a slow determining step. So once it forms clearly the R plus, then the nucleophile will come and attack. If you take a strong nucleophile, it is ready to attack. Okay, so once this R plus is formed, now it will just immediately attack. It will not even give a time. So this is very eager. So that's why in SN1 reaction, instead of strong nucleophiles, we'll go with a weak nucleophiles. So remember, SN1 reaction is very well if it is a weak nucleophile compared to the strong nucleophile. Remember this as well. So compared to the weak nucleophile is more favorable than the strong nucleophile in SN1. And the opposite for the SN2. I told you, SN2 will be attacking from the opposite direction. It should be very strong nucleophile. If you guys remember the SN2 reactions. If you don't remember, then just revise it. So SN2 reactions are more favorable when the nucleophile is strong. SN1 reaction is more favorable when the nucleophile is weak. So whatever the attacking group is there, it should be weak, not the strong one. Here C2H5O minus is very strong because it is now having a good number of electrons on this. And we know nucleophile means the one which is having good number of electrons and it is able to donate to someone. That's a good nucleophile. Here C2H5O minus is a very good nucleophile. So very strong nucleophile. So this will be not a favorable for SN1. It is favorable for SN2. So that's how he gave the same example, but he explained in two different ways. One is when it is having hydrogen, when it is not having hydrogen. Is that clear? So why the SN1 reactions are not happening in both the cases? Instead, it's happening SN2. In the first condition, here the tertiary carbon is not favorable. Sorry, primary carbon is not favorable. It should be the tertiary carbon. In the second condition, here whatever the nucleophile we are taking, it's a very strong nucleophile. As it is a strong nucleophile, it will not allow the carbocation formation to happen. So this is not favorable for SN1 reaction. It immediately try to form the SN2 reactions. So both are SN2 and SN2. Is that clear? Everyone, it will make more sense if you revise the concepts. If you don't revise the concepts, then everything looks like a completely new because it's entirely depend on the previous concepts. Here you need to know about SN2, SN1, what is a strong nucleophile, what is a weak nucleophile, which one is favorable, tertiary or primary carbon. So all these scenarios based on that, you are able to solve the questions. At least tell me this. So which of the following is least reactive in SN1 reaction? So remember, one is SN1 should able to form the carbocation. In order to form the carbocation, second one, it should be having tertiary carbon. Yeah. And one more thing I told you, there's a vinyl carbon as well. Do you remember the vinyl carbon, the one with the double carbon? We solved few questions as well. So vinyl carbon is a very stable one. So the carbon on the double. So it's a very weak, or you can say it's a less stable or least stable. So this will also not be favorable for SN1. So now tell me which could be the answer.
Option B, sir.
Yeah. So in this condition, you can see the vinyl carbon here. So there's a bond between the carbon and carbon, and this is the least stable. So this will not be favorable for SN1 reaction. And if you see the others, at least they are not the vinyl carbons. You see here. And this is the tertiary carbon. So this is the most favorable one. and this will be the second favorable. This will be the second favorable. This will be the third favorable because it is attached to the carbon which is attached to the vinyl carbon. And this is the least because it directly attached to the vinyl carbon. Understood why the option B is the least reactive? Everyone.
Yes, sir.
Yes, sir.
What about you, Shrikar? You understood this?
Yes, sir.
Mandara?
Yes, sir.
Very sad tone. Yes, sir. Sir is eating my brain. Okay, which of the following can undergo reaction via SN1 mechanism? Guys, you are paying me money, so it's not free. It's neither the school has given me this work. So I'm taking complete responsibility for every penny I'm taking. So I also make sure whether you are understanding or not. So it's okay if you guys got irritated because of me asking multiple times. I'm perfectly okay for that. But my motto is to give you the most important concept, to give you full concept, whatever that I have. So you guys trusted me more than your Saurabh sir. So yeah, which of the following can undergo reaction via SN1 mechanism? What is the answer? Can someone draw these structures and send in the WhatsApp group? Okay, do one thing. Mandara, you draw benzyl chloride. Arashvikar, you draw allyl chloride. And Dia, you draw tertiary butyl chloride. Nitya, you draw all the three.
Okay, sir.
And send me in the WhatsApp group. I'll see who will send first with
Okay,
correct.
sir.
So what is meaning of Li?
The carbon which is attached to the halogen group is attached to another carbon which has a double bond.
Yeah, you can say that, or you can say the halogen which is attached to carbon, the carbon which is attached to the sp2 carbon. So here, this is sp2 carbon, this is sp2 carbon, this is sp3 carbon. So here, the carbon attached to the double bonded carbon or sp2 carbon. So that's a allyl chloride. And what's meaning of benzyl chloride? Good. What is meaning of tertiary butyl chloride? You can see here, tertiary. When we say tertiary, when the carbon is attached to three different carbons, and it's a butyl. So you can see four carbons, chlorine. So it's a tertiary butyl chloride. What about the benzyl chloride? The benzene ring that is attached with the methyl chloride. So you can see this one is a benzyl chloride. So tell me, in these all SN1 reaction is possible or not? First condition, there is no double bonds present to the carbon. So there is no vinyl carbons at all. So are they all can able to form the SN1 reaction? Yes or no?
Yes, sir.
Okay. So see here, the benzyl chloride, it could able to form the benzyl carbocation by removing the chlorine here. So it can undergo the SN1 reaction. You can see the allyl chloride. It's also stable by the allylic carbon. So you can remove the chlorine here and it can able to form the carbocation. The same way with the tertiary one. Okay. S- So in this one will be able to more form come in the SN1. This is the most favorable. So all of these could be the answer. Understood? One thing you need to remember, it should be able to give the stable carbocation. Why it should be stable carbocation? If it is unstable, then it will want to make a bond with someone else immediately. But we know this is a two-step reaction where the first step is rate determining step. That means it has to slowly form the carbocation and it has to stay for some time and follow with the other reaction, nucleophilic attack. But immediately if it able to form the, if it is unstable and immediately it will attach with someone, instead of SN1 it will prefer SN2 reaction. If it is very unstable carbocation, then it will prefer the SN2 reaction compared to SN1 reaction. In order to be SN1 reaction, whatever the carbocation is there, it should not immediately attacked by a nucleophile. That's why we also saw it. It should be a weak nucleophile which is attacking. As it is a weak nucleophile attack, it will not immediately try and attack you. It will take some time. Okay. If it is a very unstable, then it will be easily attacked by any nucleophile. So that's why SN1 reaction should form the stable carbocation. So next one, what could be the product here? I think we have done this kind of question, almost like similar to this question. So the same way, when you treat with AgNO3, what happened? That iodine bond will break and this iodine will attach to the Az and will turn out to be AgI. And whatever the NO3 is there, it will be just left over like a NO3 minus. Now we will be getting this product. So this product will form AgI NO3 and it will turn out to be like this. So we remove the I here. So this will turn out to be CH positive charge CH3. So here, what is the carbon here? Our cation is primary or secondary or tertiary. So which carbon is this? Primary, secondary or tertiary? Guys, this carbon is attached to two different carbons. So this will be our secondary
And
carbon. Okay. So just think secondary carbocation. How many carbons it is attached? It is attached to two carbons. So it's a secondary carbocation. So we know secondary carbocation is not much favorable. It wants to try to tertiary. So what happens here? Either the methyl shift will happen or hydride shift will happen. So here it will undergo the hydride shift. So what happens here? It will turn out to be C2H5 positive. So whatever the hydrogens are there, they just moved here and here the positive cation is turned out. So whatever the hydrogen that are attached to this carbon, they move it to this carbon. So whatever the positive charge is there, now hydrogens, they are attached to this. So they turned out to be neutral. As the hydrogens are lost on this carbon, so this carbon has turned out to be positive. You understood? So how does the hydride shift happen here? Hydrogen shifts happened here. Understood or not? So whatever the hydrogen that this carbon is holding, those hydrogens were moved to this carbon. As they moved to this carbon, so it turned out to be neutral. See, you don't confuse here. C2H5 means nothing but this structure only. But I combined and I wrote it like C2H5. Understood?
Yes.
Or I can write this way if you are confusing this. So carbon, carbon, which is having CS3, and this one is having CH2. Initially, it is having only one hydrogen, but I moved another hydrogen to this. So that's why it is called as the hydride shift, as hydride is moved. So as hydrogen, I moved here. So the positive charge now moved from here to here. because this carbon lost hydrogen, negative charge it lost. So there is a positive charge was created here. So now tell me, is that a secondary or tertiary carbon, this one? So if you see, this is one carbon, this is second carbon, this is third carbon. If a carbon is attached with three different carbons, so is that a secondary or tertiary?
Tertiary.
So this is the tertiary carbon. So is it a more preferable for SN1 reaction or not? So which one is more favorable? Either this one or this one. Which one is more preferable? The left one or right one?
Right.
Yeah. So this is more preferable. So now the water will react and OH will try to attach here. So that's how it will turn out to be like this. So C2H5, where the OH also will attach here. So is this everyone understood how this happened? Anyways, you also understood what is meaning of methyl shift or alkyl shift and hydride shift. Hydride shift in the sense hydrogen is shifting. Methyl shift in the sense methyl group is shifting. Any doubts? Nitya, Mandara, you guys understood this? Sharon, Dia?
Yes, sir.
Yes, sir.
Okay. Okay, so next one is elimination reaction. We'll stop here. So I'll continue with the elimination reaction tomorrow. But yeah, you guys are not at all reading after the class is over. That I could understand.